Now let's look at a nonlinear optimization problem in the form of portfolio optimization. For simplicity, we assume in this portfolio we're just having 3 stocks, A, B, and C. And again, for simplicity, we just assume there are 4 scenarios that can happen in their returns, marked by here in this table. In scenario 1, this is the return of the 3 stock, and scenario 2, scenario 3, scenario 4. And the decision here is pretty simple. Suppose you have $1, how you're going to allocate among the 3 stocks, and your goal is to having to reach a desired level of return, and at the same time minimize your risk measured by standard deviation. So let's see how this model works. Here the decision variable are 3 numbers, and they need to add up to be 100%. And here is the average return. And how do we calculate that? Because the 4 scenarios happen with equal probability, so it's just the average of the 4. Now in each scenario, the return can be calculated by a sum product. So for example, in scenario 1, if the allocation is this percentages, sum product of the return for each stock, you get the return of the portfolio. So, and take average of that, you get your average return. So this is the desired level return is our goal, and the objective is to minimize the standard deviation of those returns. Now, one thing to notice is that the standard deviation as a function is nonlinear in the return, and therefore it is nonlinear in the decision variable. So we cannot use linear programming to solve that. Let's go to Tools and Solver, see how it works. We're gonna minimize that. So min B14 by changing our allocation, which is in B9 to D9, and we're gonna say B11 is greater than B12, which is the average return needs to be above 4.5%, and also the sum of our allocation needs to be exactly 100%, equal to 1. And everything is positive, so check this option, make unconstrained variables non-negative, and also selecting nonlinear. So as we said before, simplex doesn't work anymore. Okay, so let's solve it. And after setting it up, Excel would produce a solution. Excel will find the solution. Now, if you don't believe this is a good one, we could change it to 33 to begin with. Control Enter, and we solve it again, just to make sure it is indeed converging to the same spot. Now, as you can see, it is doing some iteration, and this is quite normal. So again, it reached this allocation, and indeed it hits the 4.5 return, and the minimized standard deviation is 15.6%. Now, we could change this average return systematically and generate this following table. Suppose we increase this to be 5%, and let's run it again. So as you might have guessed, as your average return goes up, your objective, the standard deviation, the risk also increases. So this is the resulting table. So you can see that it is actually a nonlinear curve, and this is well known in finance theory. So this is called the efficiency frontier. All right, so that's how we use a nonlinear solver to balance our portfolio.